Alright, so moving on to question 4, what I suggest again is that you read the question, pause this video, and try to solve for the answer by yourself. I'm going to give you the answer, and if you aren't able to get the correct answer, just unpause the video and walk through it with me. So the answer to this question is B, 1.75 molal. Now I'm going to go about solving the problem. So an aqueous solution has a density of 1.50 grams per centimeters cubed and contains 40% Na2B4O7 by mass. What is the molality of Na2B4O7? The molar mass of Na2B4O7 is 381.37 grams per mole. So let's go through the question. An aqueous solution has a density of 1.50 grams per centimeters cubed. So solution density equals 1.50 grams per centimeters cubed and contains 40% Na2B4O7 by mass. So what that tells us is that we have 40.0 grams of Na2B4O7 per 100 grams of solution. We can also take out one more piece of information from this first sentence, and that is that the solution is aqueous. So what this means is that the solvent in the solution equals water. And because a solution is comprised of a solvent plus a solute, well, our solute is 40 grams. Our total solution is 100 grams. So our solvent is going to be 60 grams. And that's of water. I'll write that to make that a little bit more clear. So a solution is equal to the solute plus the solvent. We were told our solution was 100 grams. We were told that our solute was 40 grams. And then for our solvent, let's say X. Solving for our solvent, we have 100 minus 40, which is 60, equals X. And that's how you found how many grams of solvent there were. Okay, moving on to the next sentence. What is the molality of Na2B4O7? So what we are solving for is molality. And what is molality exactly? Molality is the moles of the solute over kilograms of solvent. And then we were lastly given the molar mass of our solute. So the only two things we need to find are moles of solute and kilograms of solvent. Once we find those, we can just divide and solve for our molality. So let's start with moles of solute. Well, we weren't told how many moles of our solute we have, but we were told how many grams, and we were given the molar mass, so we can find our moles of solute. We were told we have 40.0 grams of Na2B4O7, and then from our molar mass, we were told that we have 381 grams per 1 mole. So we have 381.37 grams for 1 mole of Na2B4O7. Let's just cancel out these units. We know we solved for mole correctly. And let's find how many moles exactly we have. So we have 40 times, divided by 381.37 0.37. So we have 0.10489. Let me make sure that's right. 0.10489 moles of Na2B4O7. So we've got our moles of solute. Let's move on to kilograms of solvent. Well, we figured out that we have 60 grams of solvent. We did this by looking at our percent by mass, and we knew that our solution was aqueous. So we know that we have 60 grams of water, and all we have to do is get from grams to kilograms. So we have 1,000 grams in 1 kilogram of water. Cancel out the units, and let's solve for kilograms of water. So 60 divided by 1,000 gives us 0.06 kilograms H2O. And now we have kilograms of solvent. So we have everything we need to solve for molality. I'm just going to rewrite it at the bottom so that we don't lose track of all this information. So molality equals the moles of solute over kilograms of solvent. Molality equals moles of solute, which we found to be 0.10489 moles of Na2B4O7 over kilograms of solvent, which we found to be 0.06 kilograms of water. So let's just solve and see what we get. 0.10489 divided by 0.06 gives us 1.75 molal. And the unit for molality is molal or lowercase m, whichever you prefer. I prefer molal because it's easy to confuse the lowercase m with an uppercase M. And there you have your answer. It matches one we were given, and I hope this has helped.